Here is another circuit problem. So let's start by just analyzing what kind of circuit this is. So if the current leaves the positive end of the battery, it comes along, but it hits this point where it can either go this direction or this direction. And so it has a choice. It can either go through this resistor or this resistor. So this is not considered series, this is considered parallel. So we're going to treat this a little differently, although we will start off the same way. We are going to write down all our resistors. So let's call this resistor 1, let's call this resistor 2. So we've got resistor 1, resistor 2, and as always a total. Across here we've got V, I, and R. And again, we want to start just by filling in everything we know. So the total voltage is 8 volts. And we know resistances, this is going to be 40 ohms, this is going to be 20 ohms. And that's all I have so far, at least what's given in the problem. So unlike series, we can't just add up the resistances to get the total. This actually is going to end up being less than 20 ohms. When you're in parallel, you actually end up with lower resistances. And there's a formula for that, but I'm going to stay away from it for now, and let's just analyze this another way. In parallel, the voltages, the way voltage works is that you have to, from going from the positive end to the negative end of the battery, you're going to lose 8 volts. And so if I take this path through this resistor, that means 8 volts must have been lost along that path. So that means the voltage of resistor 1 is in fact 8 volts. And that means if I were to take a different path from here and I went around and crossed this resistor and go back, that means that resistor 2 is also going to be 8 volts. So in series, the voltage is added up because you had to go through multiple resistors to get back. Here, because you're just going through one resistor, you lose all your voltage going across that resistor. So in parallel, the voltages are all going to be identical. In series, the currents are all identical. In parallel, the voltages will all be identical. So now, I know 2 out of 3 for both of these lines. So let's figure out what I is. So I use Ohm's law, which is V equals I times R. So in this case, 8 equals I times 40. So I'll divide by 40. So 8 divided by 40. And I get the current for this one is 0.2 amps. And for this one I have, again, the voltage is 8. 8 equals I times 20. So I'll divide both sides by 20. So 8 divided by 20, I get 0.4 amps. And you'll notice that resistor 2 has a higher current, and the reason is because it has a lower resistance. It's kind of like if you were sitting in traffic and you reach this point here, you had a choice. Do you want to go the larger resistance or the lower resistance? More people are going to choose the lower resistance until it gets backed up, and then more people will go to the 40. The point is, the resistor with the lower resistance is going to get more traffic, more current, and that should make sense. So the voltages are always the same in parallel. The one thing that does add up in parallel, however, is the current. If I have 0.2 amps traveling on this circuit part and 0.4 amps traveling on this segment, when they meet back up here, you're going to end up with 0.6 amps because the currents have to add up along each wire. So my total current is 0.6 amps. Okay? So I have everything filled out except for my total resistance. So again, I can use Ohm's law. I know that voltage 8 equals current 0.6 times the total resistance. So that means 8 divided by 0.6 is my total resistance. And that means my total resistance is going to be 13.33 ohms. And this might seem strange. Your resistance is actually lower. And that's good. In parallel, the more resistors you have, the lower the overall resistance is going to be. The best way I can think of it is, let's say that we had one particular road going home, 40 ohm road. Let's say that this road is closed completely. You're going to have 40 ohms of resistance. But when you open up a new road, let's say I open this back up, that's another path for the electricity to take. It makes the overall resistance go down. So in parallel, the voltages are always going to be the same. The currents are going to add up. And your overall resistance is going to be lower than your lowest resistance. So the lowest resistance is 20. My overall is going to be lower than that if I do it properly. And there's a formula to figure this out. I will do that probably in another video at some point. For now, you don't actually need that formula to solve this. You just need to know that the voltages are the same, the currents add up, and then you can usually back calculate that. So that's it. Until next time, I am Derek Genova. Have a delightful day.